So our first trend we're going to look at is atomic radius. So as we increase the atomic number within a group or go down a group, each atom has another energy level. So the atom gets bigger. Lithium has one more shell than hydrogen, so lithium is a little bit bigger than hydrogen. Sodium has one more shell than lithium, so it's a little bit bigger. You get the idea. It's like building layers of a snowman. Each atom below has one extra shell, so it's that much wider. As we go across the period from left to right, the size gets smaller. The electrons are in the same energy level, so they have the same number of shells. However, there's more nuclear charge as we go to the right. Argon has more protons in its nucleus than sodium does, so it has more of a pulling power, and it can get those outermost electrons pulled closer to it, and that's why the size gets smaller as you go across the period. So this diagram here shows the various periods. Here's period 2. You can see as you go down the group, the elements are getting smaller. As we go to period 3, it starts bigger because period 3 has 3 shells, where period 2 only had 1, but we see the trend as it still gets smaller as you go across. As you see in this one here, there's some little bumps here. There's some exceptions, and we'll talk about that in class, but these exceptions are things that I or the Regents aren't going to test you on. You need to know the general trend, not all the little tiny exceptions. Okay, this line I'm tracing here shows us the group trend. So this is group 1. As you can see, as we go down group 1, an increase in atomic number, the atomic radius gets bigger because each element has one extra shell compared to the element before. So remember, as you go down a group, atomic radius gets bigger because each element has more shells. And as you go across a period, the atomic radius gets smaller because each element has more positive protons to pull those negative electrons in closer.